Welcome. In today's video, we're going to be solving linear systems using a graphing calculator. So by the end of this video, you should be able to work problems like these two types. The first type is you're just going to be able to identify either the solution from a graph or the number of solutions from a graph of two lines. The second one is you're actually going to be given a linear system, which is just two equations, and you're going to find the solution to that linear system using a graphing calculator. To get us started, we've got a definition, which is a solution to a linear system. All that is the point where the two lines intersect. So, got a question for you right here. Where do these two lines actually intersect each other? And if you follow the lines down, you'll notice that they intersect each other at this point right here. At the point 2, comma, that's a -1. So where do the two lines intersect? They intersect at 2, comma, -1. That's the solution to the linear system. So if you're asked what is the solution to this linear system, you're really being asked where do the two lines intersect. The answer is still the same. It's still 2, comma, -1 because that's the point where the two lines cross each other. So taking a look at this example, what's the solution to this linear system? This is kind of a trick question. The two lines will never intersect, ever. And how you can know that for absolute sure is by looking at the slopes of the two lines. So again, there's no solution because the lines are parallel. They never intersect, but we can check that for absolute sure by checking the rise over run. Just find 2 points on the line and find your rise. In this case, rise is 2 and run is 1. So the slope of the blue line is 2, so slope equals 2. Let's check the slope of the red line. Just pick 2 points on the red line. Find your rise over your run. That's 2 over 1. So the slope of the red line is also 2. Anytime your slopes are exactly the same, that means that you have no solution because the lines never intersect. This one's going to be a little bit more difficult to see. What is the solution to this linear system? Now notice the blue line, it's a light colored blue, is directly on top of the red line. So what's the solution to this linear system? Remember, the solution is where the two lines intersect each other. Problem with this is the lines will intersect each other at every single point along the line. So since the line goes on forever in both directions, there are actually infinitely many solutions. So you say anytime you have the exact same line twice, one touching each other everywhere, you say that there are infinite solutions. Here's one for you to try. What is the solution to this linear system? Well, the answer is where the two lines intersect, and the two lines intersect right there, which is at, this is -6 on the x-axis. This is a -3 on the y-axis, so that point right there is -6, comma, -3. So the solution to this linear system is -6, -3. There are times when you're going to be asked the question a little bit differently. What is the x-coordinate of the solution, or what is the y-coordinate of the solution? Well, the steps are exactly the same. You just find out where the two lines intersect each other. In this case, they intersect each other at -6, -3 again. But that is the ordered pair. That contains both coordinates. So if you're asking for the x-coordinate, you just write it down, -6, because that's the x value of that intersection. What's the y-coordinate? The y-coordinate is -3 because that's the y value of the coordinate where the two lines intersect. Here's one for you to try on your own. What is the solution to this linear system? Go ahead and pause the video, work it out, press play when you're ready to see the answer. Trick question, the two lines are parallel, and we know that for sure because the rise over run of both lines is -1 over 1. Same for the other line, -1, we go down 1, the run is +1. So since they have the exact same rise over run, the lines are parallel, so you know that there are no solutions. And to switch things up a bit, try this one out. It's a little bit different, so think about it very carefully before you answer. How many solutions does this linear system have? Could be one, could be none, or could be infinite solutions. Well, you know that there are no solutions if the two lines are parallel, so we have to find the slope of both of our lines. To do that, we pick two places where it crosses through the corner of the grid. We find the rise over the run. In this case, our rise is 1, 2, 3, 4, so our rise is a positive 4. Our run is a positive 2. You could have done 2 over 1, would have worked exactly the same. Either way, the slope of the red line is 2. Let's check it out. The slope of the blue line. Pick two places where it crosses through the axis, and can't really find two places. Makes it a little bit more challenging. Looks like it might cross really close right there, but let's check it out. Rise over run, up 1, 2, 3, to the right 1, 2. Well, it's not the same slope, and you could kind of tell that from the graph just by looking at the two lines. They're tilted very slightly towards each other, so you don't have the same slope. The lines will eventually cross each other somewhere. So how many solutions are there? There are, or is, one solution. How do we know that again? The slopes are not exactly the same. Now we're actually going to solve a linear system, and there are several steps we're going to go through in order to solve it using our graphing calculators. So go ahead and pause the video, get out your graphing calculator, turn it on, and press play when you're ready to move on. Here are the steps. We're going to get both equations into y equals mx plus b form. Then we're going to press the y equals button, type the equation into the y equals screen. Then we're going to press these buttons, second, trace, intersect, and then we're going to press enter 3 times, and that will give us the solution of the linear system where the two lines intersect. Alright, let's go ahead and take a look at that first example. Find the x-coordinate and the y-coordinate of the solution to the linear system. So remember, there are several steps we need to go through in order to make that happen. The first step is we've got to get both equations into y equals form. So I'm going to rewrite 2x minus y equals 5 here, and I'm going to get y by itself. The steps to getting y by itself are always the same if it looks like this. You remove the x from the left-hand side, so we're going to take 2 x's away from both sides. We're left with negative y is equal to negative 2x plus 5. Notice I write negative 2x plus 5 because it's a positive 5, and I have to get rid of that negative on the y since it was a negative y that we brought down. To do that, we divide everything by negative 1, and we get y is equal to a positive 2x because negative 2 over negative 1 is a positive 2, plus 5 over negative 1 is minus 5. We have our first equation. That's not the answer, but I'm boxing it just to let myself know that's our first equation. And for our second equation, we have 3x plus 2y equals 18. So we're going to take away 3 x's from both sides. We're left with 2y is equal to a negative 3x plus 18. And I'll finish this equation up here. Gives us 2y again is equal to negative 3x plus 18. So divide everything by 2, all terms on both sides, and we get y is equal to negative 3 over 2, that's a 3. X plus 18 over 2 is plus 9. So we have both equations into y equals form. Now what we're going to do is to type those two equations into your y equals screen. So get your calculator, turn it on, and get to your y equals screen. You're going to need both equations. Our first equation was 2x minus 5. So to do that, you type 2 and then you type x, and then you go minus. Make sure you type the minus button, which is above the plus button, not the negative. 5. And for the second equation, we have negative 3 halves x plus 9. So the way we do that is negative. Make sure you type the negative below the 3. 3 halves. To make 3 halves, you just go negative 3 divided by 2, x. And it was a plus 9, so we go plus 9. Now that you have both equations in your calculator, you go second, trace. Notice it says the word calculate, and we're going to calculate the intersection of the two lines. Press enter. It should draw both lines on your graphing calculator, and you press enter, enter, enter until you see the intersection. Our intersection is 4, 3. So the solution to this linear system is 4, 3. We're going to want to split that up into the x-coordinate, 4, and the y-coordinate, 3. So the x-coordinate of our solution to our linear system is 4. The y-coordinate of the solution to our linear system is 3. Here's one for you to try on your own. Go ahead and pause the video, work it out, and press play when you're ready to see the answer. Alright, we got to get y by itself in both equations. I'm going to go ahead and move the x minus 2y equals 5 right here so I can solve it separately from the 14x plus 4y equals 6. So x minus 2y equals 5. To solve this system, what we're going to do is we're going to subtract x from both sides first. That cancels. We're left with negative 2y is equal to negative x, and that's a positive 5. Divide both sides by negative 2, and we get y is equal to negative over negative gives us a positive x over 2. Positive 5 over negative 2 gives us a negative 5 halves. For the other equation, we subtract 14x from both sides. This gives us 4y is equal to negative 14x plus 6. Divide both sides by 4. We get y is equal to, those can be reduced, giving us negative 7 halves x plus 6 over 4 gives us 3 halves. So those are your two equations. You go ahead and type both those equations into your graphing calculator. And I've got both those equations typed into the calculator. The next step is we go second trace, go down to the word intersect, press enter. After it graphs, we press enter 3 times. Enter, enter, enter. Notice if you press enter while it's trying to graph, it's just going to pause the graph. So to get it to unpause, you just press enter again. And you want to press enter 3 times till you get to the word intersection 1, negative 2. Now let's look at the question. It says find the x-coordinate of the solution to the linear system. This one's, well, even easier than the previous one. All we need is the x value of that solution. So the answer is x is equal to 1. That's the x-coordinate to the solution of the linear system.